Hey everyone, welcome back. Today we're going to be taking a deep dive into the world of databases
Okay.
with this source, database terms and concepts, a primer,
Cool.
and we're going to be going like beyond just basic definitions.
Right.
We're going to try to like really get behind the scenes and see how all the data in our digital lives,
Yeah.
you know,
Yeah.
gets organized,
Mhm.
ready to unlock those secrets.
Absolutely. And it's really surprising how many people interact with databases
Right.
every day without realizing.
Totally.
Yeah.
So let's start with like the foundation, the schema.
Okay.
The source kind of describes it as the blueprint.
Yeah.
But it's more than just a static plan,
Right.
right?
It's like DNA for your data.
Oh,
A well-defined schema, like the example Candy2 in the source,
okay.
dictates how information is structured and how different pieces relate,
Got it.
which is key for keeping things organized, as the database grows.
Okay, so within that schema, we've got tables,
Right.
which the source compares to spreadsheet.
Mhm.
But what makes a database table different from just any old spreadsheet?
It's all about the relationships.
Okay.
In a spreadsheet, it's just rows and columns of data. But
Yeah.
database tables are designed to connect with each other through
Right.
keys, which we'll get to in a bit.
Right.
But that interconnectedness is what makes databases so powerful.
Got it. So it's less about just storing data
Yeah.
and more about creating a web of information
Mhm.
that can be accessed
Absolutely.
and analyzed in different ways.
Mm.
The source mentions fields, attributes, and columns almost interchangeably.
Yeah.
Is there a subtle difference?
Yeah.
Or are they basically the same thing?
For practical purposes, you
Right.
can think of them as the same.
Okay,
They all refer to the specific pieces of information
got it.
stored in each column of a table. So
Right.
in a table about employees,
Yeah.
job title would be a field, an attribute, and a column
Okay.
all at once.
Okay, that makes sense.
Yeah.
And each row, or record, as the source calls it,
Mm-hmm.
represents a unique entry,
Yes.
like an individual employee in that employee table.
Exactly. Each row paints a complete picture of that specific entity,
Right.
all the attributes that define it
Okay.
within the database.
Now on to those all-important keys.
Right.
The source highlights primary keys
Mm-hmm.
as unique identifiers for each record.
Yeah.
It's like each employee having a unique ID number.
Exactly. And that's crucial
Right.
because it prevents duplicates
Right.
and ensures you can always pinpoint the exact record you're looking for.
Got it.
Figure 5 in the source actually visually highlights this PK field so you can see it in action.
Okay, cool.
Yeah.
But data doesn't exist in isolation, right?
Right.
That's where foreign keys come in.
Exact.
Creating those relationships between tables that you mentioned earlier.
They act like bridges connecting tables based on shared information.
Okay.
For example, in the orders table from the Candy2 schema, you might have a foreign key that links each order to a specific customer in the customer's table.
Got it.
This is what lets you see all the orders placed by a single customer, for instance.
Okay.
And if you look at figure 6,
Okay.
you can see how those FK and PK fields
Yeah.
work together to make that connection.
So you can trace a single piece of information through multiple tables,
Yeah,
like following a trail of breadcrumbs.
exactly.
And the source mentions a common type of relationship called one-to-many.
Mm-hmm.
Can you give us a real-world example of that?
Think about a customer placing orders.
Okay.
One customer can have many orders,
Right.
but each order is linked back to that single customer.
Got it.
That's a classic one-to-many relationship.
Okay.
And figure 7 visually breaks it down for you.
That's helpful. It's starting to feel like solving a puzzle,
Yeah.
seeing how all these concepts fit together to build a database.
Right.
Now, the source shifts gears to talk about entities and attributes. Are these like the building blocks of those relationships we just talked about?
They are the core components of your data model.
Okay.
An entity is essentially a real-world object or concept that you want to track in the database,
Got it.
like a product or an employee.
Okay.
And each entity has specific characteristics called attributes that describe it.
Right.
So for a product entity, you might have attributes like name, price, and description.
So it's kind of like a hierarchy. You have the schema,
Right.
then the tables that organize the entities.
Exactly.
And within those tables, you have the attributes that describe those entities.
Precisely.
Yep.
And the source then goes on to emphasize the importance of integrity constraints.
Okay.
These are the rules that keep the data accurate and consistent.
Got it.
Imagine trying to add a duplicate employee ID.
Right.
A good database design will flag that as an error thanks to these constraints.
It's like having a safety net built right into the system.
Exactly.
I'm guessing there are different types of these constraints.
Yes. The source highlights primary key constraints
Okay.
and foreign key constraints, specifically.
Okay.
Primary key constraints ensure that each record has a unique identifier,
Right.
like we talked about earlier.
Got it.
And those foreign key constraints
Mm-hmm.
make sure that the relationships between tables stay valid.
Right.
Figure 9 even shows you what happens if you try to insert a duplicate primary key,
Oh.
red alert,
Yeah.
error message.
It's interesting to see how much thought goes into preventing errors
Mm-hmm.
and keeping the data clean.
Yeah,
Now, the source brings up redundancy.
right.
It sounds like something you'd want to avoid in a database.
Well, it depends.
Okay.
Some redundancy can be intentional,
Okay.
especially when you're optimizing for performance.
Right.
But too much redundancy can lead to inconsistencies
Got it.
and storage headaches.
Like having duplicate files scattered all over your computer.
Exactly. And that's where the concept of referential integrity comes in. It ensures that the relationships between tables are valid and consistent.
Got it.
If an order references a customer, that customer has to exist in the customer table.
Right.
No phantom customers allowed.
Right.
Figure 11 actually shows an example of this, where an attempt to insert a child record without a matching parent is rejected.
Interesting.
It even includes the SQL code and error message,
Oh, wow.
which is a cool peek behind the scenes.
That's fascinating. It's like the database is double-checking
Yeah.
every relationship to make sure it makes sense.
Mm-hmm.
So we've covered a lot of ground here.
Yeah, we have.
Schemas, tables, keys, relationships,
Right.
integrity constraints,
Yes.
and even the potential pitfalls of redundancy. It's really starting to paint a clear picture
Mm-hmm.
of how a database is structured
Yeah.
and how those structures help ensure data integrity.
And the source does a great job of connecting those individual pieces together.
Right.
They emphasize that understanding these core concepts.
Is really the foundation for designing and managing
Got it.
any database system effectively.
It feels like we've been given the keys to the kingdom.
I like that.
But before we get too comfortable with these building blocks,
Okay.
there's something I'm curious about.
Yeah.
The source mentions avoiding redundancy,
Right.
but also making sure data is easily accessible.
Yeah.
How do database designers find that balance?
That's a great question.
Yeah.
And one that really gets to the heart of the challenges
Right.
in database design.
Mm.
Because you're absolutely right. There's a
Mhm.
tension between minimizing duplication
Right.
and ensuring that data is readily available for analysis and processing.
It's like a balancing act, right?
Exactly. And the solutions often involve trade-offs.
Oh, okay.
Sometimes you might introduce a little bit of redundancy to
Yeah.
improve performance, even though it goes against the principle
Right.
of keeping things as lean as possible.
Got it.
It's a constant game of optimization,
Yeah.
figuring out what works best.
Yeah. For the specific needs of the database
Mm-hmm.
and the applications that rely on it.
So there's no one-size-fits-all solution.
Exactly.
It depends on the specific context and
Right.
what the database is trying to achieve.
Precisely. And that's why database design can be such a fascinating and complex field.
Okay.
It's not just about understanding the mechanics
Right.
of how a database works, but also about making strategic decisions
Got it.
to balance competing priorities.
Well, I think we've successfully navigated
I think so.
the first layer of this database labyrinth.
Yes,
We've gone from schema to redundancy and everything in between.
that's right.
But it sounds like there's a whole lot more to explore beneath the surface.
Absolutely. And that's what makes databases so compelling.
Right.
There's always another layer to uncover,
Right.
another challenge to solve.
So to our listeners,
Yeah.
take a moment to think about the databases you interact with every day,
Mm-hmm.
from your banking app to your favorite social media platform.
Yeah.
What kind of information are they storing?
Right.
How are they organizing that data
Yeah.
to make it easily accessible?
Mm.
And what are the challenges they face
Right.
in balancing data integrity with performance?
Good question.
We'll pick up this conversation next time
Okay.
and dive even deeper into the world of database design.